Dear students, good morning. Today we will be continuing problems on discrete time Fourier transform. The problem statement is find DTFT of the rectangular pulse x of n is equal to 1 for mod n less than or equal to m, 0 otherwise. Also sketch amplitude and phase spectra. Again I repeat, spectra is the plural of spectrum. Before going to this problem, I want to tell you some important oscillating functions. Note. Important oscillatory functions. First one, sinc x. This is defined as sin pi x divided by pi x. Sinc x appears like this when plotted. Y-axis is sinc x. You have got an oscillating sine function like this. The oscillations keep decreasing as x increases. At x equal to 0, the amplitude is 1. This is called sinc function. The second function I am going to take is saw function. Saw function means, second one, saw function. Saw of x. It is nothing but sin x divided by x. This will have same shape as that of sinc function. Let me plot it. This is x. Y-axis is saw of x. Again we have got an oscillating sine function. The oscillations keep decreasing and finally they become 0 at x equal to plus infinity and minus infinity. And when x equal to 0, the value is 1. This is called saw function. Saw of x equal to what? Sin x by x. The third function is sin ax divided by sin bx. This function also is an oscillatory function. Y-axis I take it as sin ax divided by sin bx. The oscillations keep decreasing as x increases. And these functions are even functions of x. When x equal to 0, the value here, depends upon, we have to apply in fact here, L'Hospital's rule to find the value at x equal to 0. When x equal to 0, differentiate numerator, differentiate denominator. When you differentiate numerator, you get a times, what is L'Hospital's rule? Limit x tending to 0 and d by dx of sin ax divided by d by dx of sin bx. If you do this, if you differentiate numerator, you get a times cos ax. If you differentiate denominator, you get b times cos bx. Then take the limit x tending to 0. So what you get? You get a value equal to a divided by b. When x equal to 0, it is a divided by b. By using L'Hospital's rule, I have found what is the value of sin ax by sin bx at x equal to 0. If you put x equal to 0, you see that numerator will be 0, denominator will be 0, you get 0 by 0 indeterminate form. Therefore, we use L'Hospital's rule. We differentiate numerator with respect to x. We differentiate denominator with respect to x. Then take the limit x tending to 0. These are all called zero crossings of the oscillating functions. To find these zero crossings, what we have to do? Sin bx by sin x should be put equal to 0, and then we have to find the values of x. That I will demonstrate in this particular problem. So 3 oscillating functions I have discussed. Now we come to the actual solution. X of e power j omega equals, by definition, summation n equals minus infinity to plus infinity, x of n into e to the power minus j omega n. Mod n less than or equal to n means the function looks like this. Please watch. X-axis is n, y-axis is x of n. Let us say this is n equal to 1, 2, 3, minus 1, minus 2, minus 3. For the sake of analysis, I will take this as minus m, I will take this as plus m. M is 3 over here, here minus m is minus 3. So you get a pulse like this. This is a rectangular pulse which is even symmetric. All the samples have got unit value. I have drawn this figure for m is equal to 3. Mod n less than or equal to m means n varies from n. This implies what? This implies n varies from minus m to plus m. I have taken m equal to 3 for demonstrating why this is called a rectangular pulse. Now this function is 0 for other values as suggested here. Other values of n. Now I will substitute this value of x of n over here. That gives me x of e power j omega equals summation n equals minus m to plus m. X of n value is 1 into e to the power minus j omega n. Our next objective should be to make the lower limit of summation equal to 0. Therefore, we use a substitution. Put n is equal to n plus m. When n equals minus m, L equals 0. When n is equal to plus m, what is L? L is 2m. Now when we make use of the substitution in this summation, that gives us x of e to the power j omega is equal to summation L is equal to 0 to 2m e to the power minus j omega. What is n? What is n? N is L minus m. So here e to the power j omega m you take out of the summation. Summation L is equal to 0 to 2n e to the power minus j omega whole to the power L. Recall, important substitution, recall, summation n is equal to 0 to n on a to the power n equals 1 minus a to the power n plus 1 divided by 1 minus a not equal to 1. Here what is a? E to the power minus j omega. And what is capital N? 2m. We'll apply this formula to this summation. That gives us x of e power j omega is equal to e to the power j omega m into 1 minus e to the power minus j omega 2m plus 1 divided by 1 minus e to the power minus j omega. Now we will simplify further. This implies x of e power j omega is equal to e to the power j omega m. In the numerator, I will take e to the power minus j omega 2m plus 1 divided by 2 common. Then what will be the terms in the numerator? E to the power j omega 2m plus 1 divided by 2. See, if you multiply these two exponentials, you get e to the power 0, which is 1. Minus e to the power minus j omega by 2 into 2m plus 1. In the denominator also, I will take e to the power minus j omega by 2 common. If you take common, what happens? You get e to the power j omega by 2 minus e to the power minus j omega by 2. Multiply these two exponentials, you get e to the power 0, which is 1. When you multiply these two exponentials, the powers get added, so you get this exponential. Now if you take this exponential to numerator, add all the powers of the exponentials, you get e to the power 0. Divide this numerator by 2j, denominator by 2j. What I want to say is e to the power ax, e to the power j times ax minus e to the power minus j times ax divided by e to the power j times bx minus e to the power minus j times bx is what? Is nothing but this we can write as e to the power j times ax minus e to the power minus j times ax divided by 2j divided by e to the power j times bx minus e to the power minus j times bx divided by 2j. This is a note. So numerator is what? Numerator is now sin ax. Denominator is what? Sin bx. This formula is applicable over here. This is like e to the power j times ax minus e to the power minus j times ax. This is like e to the power j times bx minus e to the power minus j times bx. So you get what? Sin of omega by 2 into 2m plus 1 divided by sin of omega by 2. We have to avoid indeterminate form here. Indeterminate form is numerator 0, denominator 0. That will happen when omega is 0. You get sin 0 is 0. Here also sin 0 is 0. 0 by 0. Avoid that. Therefore, I will put a condition. Omega cannot be 0. Omega cannot be plus minus 2 pi. Omega cannot be plus minus 4 pi and so on. These conditions ensures you don't get 0 by 0 type of fraction. Now how to find x of e power j omega at omega equal to 0, comma, plus minus 2 pi, comma, plus minus 4 pi dash dash. We can use either L'Hospital's rule, or we can use the defining equation. In the defining equation, I have written what is x of e power j omega. We have written x of e power j. I will just say we know that x of e power j omega is equal to x of e power j omega is equal to what? Summation n equals minus n to plus n minus m to plus m, minus m to plus m, n is equal to minus m to plus n, 1 into e to the power minus j omega n. In this expression, put, hence, you please watch, in this expression put omega equal to 0, plus minus 2 pi, so on and so forth. Hence, x of e power j omega evaluated at omega equal to 0, comma plus minus 2 pi plus minus 4 pi dash dash. If you put omega equal to 0, what you get? You get summation n equal to minus m to plus m 1. 1 if you add from minus m to plus m, you get result 2m plus 1. Upper limit minus lower limit is 2m plus 1. Why that plus 1? Because there is a value n equal to 0. So this is the value of x of e power j omega at omega equal to 0 plus minus 2m plus minus 4m 4 pi plus minus 2 pi plus minus 4 pi and so on. I am going to now summarize. I am going to summarize now. Summarizing this slightly complicated problem. Summarizing we get x of e power j omega equals sine of omega by 2 into 2m plus 1 divided by sine of omega by 2. Condition here is omega cannot be equal to 0, comma, plus minus 2 pi, comma, plus minus 4 pi dash dash. Equals 2m plus 1 when omega equals 0, plus minus 2 pi, comma, plus minus 4 pi dash dash. So this is how DTFT of the rectangular pulse is found. Now we want to plot this spectrum. For plotting the spectrum, you see here, this is like sine AX by sine BX, oscillating function, which I described in the starting of the problem. To find zero crossings of x of e power j omega. To find zero crossings of x of e power j omega. I again repeat, x of e power j omega, these values of omega can be found by two ways. First, by substituting these values in the defining equation. Second, by applying L'Hospital's rule. But first method is easier, therefore follow that method in the examination. To find zero crossings of x of e power j omega, let x of e power j omega be equal to 0. That means this implies sine of omega by 2 into 2m plus 1 divided by sine of omega by 2 be equal to 0. Cross multiply. When you cross multiply, you get sine of omega by 2 into 2m plus 1 equal to 0. This implies omega by 2 into 2m plus 1 is equal to plus minus k into pi. K takes values 1, 2, 3 and so on. This in turn implies omega is equal to cross multiply plus minus 2k pi divided by 2m plus 1. K takes values 1, 2, 3 dash dash. This is how we get zero crossings of x of e power j omega. So I said that this is like sine AX by sine BX form. We get an oscillating function. That function I am going to plot now. And we'll plot from minus pi to plus pi. You will see the board now. X-axis is omega, y-axis is x of e power j omega. I take equal intervals on x-axis. Let us say this is pi. This is minus pi. Now the function is oscillating. The oscillations keep decreasing. This figure is even symmetric. This figure is even symmetric. This figure is even symmetric. When omega is 0, the value is 2m plus 1. This is called first zero crossing. This takes place where when you put here k equal to 1, what you get? You get 2 pi divided by 2m plus 1. Minus sign accounts for this zero crossing, which is minus 2 pi divided by 2m plus 1. When you put k equal to 2 over here, you get this zero crossing. What is this zero crossing? This zero crossing is 4 pi divided by 2m plus 1. And this zero crossing, second zero crossing is minus 4 pi divided by 2m plus 1. This figure is periodic. This figure is periodic, and fundamental period equals 2 pi. This figure is periodic. FP means fundamental period equal to 2 pi. This is how x of e power j omega with respect to omega is plotted. This is called complex spectrum. This is called complex spectrum. Now from this spectrum, I have to get the magnitude spectrum. Please watch. From this figure, I have to get magnitude spectrum. Magnitude of x of e power j omega. When you take modulus of a negative number, that number becomes positive. That means when you take modulus, these negative cycles will become positive cycles. You will get a figure like this. This is pi. This is minus pi. This value is 2m plus 1. What is the zero crossing? This zero crossing is at 2 pi divided by 2m plus 1. This zero crossing is at 4 pi divided by 2m plus 1. When you take modulus, these negative cycles will become positive cycles. This is nothing but amplitude spectrum. First I have drawn the complex spectrum. Complex number has got amplitude and angle. This is the plot of amplitude of that complex number. You can treat it that way. Next, some important things I want to tell you. Note, if you have a number A, its magnitude is A, angle is 0. If you have a number minus A, its amplitude is A, angle is pi when K less than 0. Or we can say, instead of K, I will write here omega, when omega is less than 0. A at an angle minus pi, omega greater than 0. See, the reason for this is, minus A we can write as minus A we can write as A at an angle plus minus pi, which is A times cos of plus minus pi plus J times sin of plus minus pi. Sin of plus minus pi is 0, cos of plus minus pi is minus 1, so you get minus A. So what is important is, minus A has an amplitude plus A, angle could be plus pi or minus pi. I have taken the angle as plus pi for negative values of omega. The angle as minus pi for positive values of omega. You may ask me a question, why? The reason is, phase spectrum must exhibit odd symmetry. Phase spectrum must exhibit odd symmetry. X-axis is omega here, y-axis is theta omega. This positive cycle can be treated as A. Therefore, what is the angle of it? Angle of it is 0. Therefore, you get a line like this. Angle is 0. This is negative half cycle, and this negative cycle occurs for positive value of omega. Therefore, what is the angle contributed by it? Minus pi. Therefore, this negative cycle, I'll represent by a rectangular pulse whose amplitude is minus pi. Next, this is now positive cycle. Therefore, what is its angle? 0. Therefore, the angle is 0. Again, this is negative cycle. Therefore, what is its angle? Its angle is minus pi. Angle is minus pi. I again repeat, positive cycle is like A, angle 0. Negative cycle, this negative cycle occurs for positive value of omega, therefore the angle must be minus pi. Now come over here. This negative cycle occurs for negative values of omega, therefore what is the angle? Plus pi. Plus pi. This is positive half cycle, therefore what is its angle? Its angle is 0. Then we have got negative half cycle, you see here. And this negative cycle, not negative half cycle, negative cycle. Negative cycle, what is the angle? Minus pi. Sorry, plus pi. So this is phase spectrum. Since x of n is real, amplitude spectrum exhibits even symmetry, phase spectrum exhibits odd symmetry. This is how from the complex spectrum I have extracted amplitude spectrum and phase spectrum. I have extracted from this figure amplitude spectrum and phase spectrum. If you want to correlate this in control system, this could be Nyquist plot, this could be Bode's magnitude plot, this could be Bode's phase plot. Only difference is here y-axis is not in decibel scale. That's the only difference. I think this problem is clear now. This problem needs to be practiced, asked several times in the examination. The most difficult part of this is to plot the amplitude spectrum and phase spectrum. You might ask me why I have taken minus pi for omega greater than 0. Here, if instead of writing plus pi, if you write the pulse of minus pi, then here you should write the pulse of plus pi. That is still accepted because it will exhibit odd symmetry. As a matter of convention, all authors, they take angle as minus pi when omega is greater than 0, the angle as plus pi when omega is less than 0. This is a matter of only convention. Even if this convention is reversed, nothing is wrong. With this, we conclude this problem. I will now go to the next one. Find DTFT of the signals given below. Y-axis is x1 of n. There are five samples. Or I'll restrict to 3 samples, minus 1, 0, 1. Rest of the samples are 0. All the samples have unique value. X-axis is n, y-axis is x2 of n. Here also there are only 3 samples. All the samples of unique value. This will be referred to as figure 1. This will be referred to as figure number 2. Now we have to find DTFT of these 2 signals. This problem is a special case of previous problem with m equal to 1. But here I will solve the same problem using this different approach. Not different approach, but in a simplistic manner. Solution. x1 of e power j omega by definition is summation n equals minus infinity to plus infinity x1 of n into e to the power minus j omega n. This implies x1 of e power j omega equals summation n equals minus 1 to plus 1. What is x1 of n? 1 into e to the power minus j omega. Expand this summation now. When n is minus 1, you get e power j omega. When n is 0, you get 1. When n is 1, you get e power minus j omega. Note, e to the power j theta plus e to the power minus j theta divided by 2 is cos theta. This implies e to the power j theta plus e to the power minus j theta equals 2 times cos theta. Now e power j omega plus e power minus j omega are complex conjugates. I can combine them and write 2 cos omega. Therefore the result is 1 plus 2 times cos omega. This is how x1 of e power j omega is formed. Now what is x2 of n? From figures 1 and 2, we can write, see, x2 of n is nothing but x1 of n shifted to right by one time index. We can write x2 of n is nothing but x1 of n minus 1. Applying time shift property, we get what? x2 of e power j omega is equal to e to the power minus j omega into x1 of e power j omega. x1 of e power j omega is what? x1 of e power j omega is 1 plus 2 times cos omega. Like this, DTFT of x2 of n can be found. If you know DTFT of x1 of n, then you should also know time shift property. This is how this problem can be solved. Or instead of doing this way, if you can remember the result of the previous problem, in that put m equal to 1. But you will get the answer in terms of sin ax by sin bx type. Here you get the answer in terms of cosine function. But both the equation will give you identical values for different values of omega. Next problem. Find DTFT of x of n equal to delta of n. Also plot amplitude and phase spectra. Solution. We know that x of e power j omega by definition is summation n equals minus infinity to plus infinity x of n into e to the power minus j omega n. In this context, what is x of n? Delta of n. Hence, x of e power j omega is equal to summation n equals minus infinity to plus infinity delta of n into e to the power minus j omega n. Applying shifting property, we get x of e power j omega equals e to the power minus j omega n gets evaluated at n equal to 0. n equal to 0 is nothing but the location of delta of n. So you get value equal to 1. What is the angle of 1? Note, 1 means 1 at an angle 0. Since the angle is 0, the phase spectrum is a null spectrum. Null spectrum means there is nothing in the spectrum. I now plot magnitude spectrum. Y-axis is magnitude of x of e power j omega. X-axis is omega. I plot always the spectrum from minus pi to plus pi. What is magnitude of 1? Magnitude of 1 is 1 only. Even this spectrum is periodic. Fundamental period, Fp means, in the exam don't write Fp, exponent write. Fundamental period equals 2 pi. What is phase spectrum? Phase spectrum is a null spectrum. Because the angle of 1 is 0. Therefore, phase spectrum when you plot from minus pi to plus pi, it is 0. Therefore, it is called null spectrum. This is how we find DTFT of x of n equal to delta of n. then I have shown how to plot the amplitude spectrum and phase spectrum. Both the spectrum are periodic. Even this is periodic. But it makes no sense if you write periodic because it's a null spectrum. Periodic and fundamental period of this also is 2 pi. But since a null spectrum, periodicity has got no meaning over here. With this we stop. Thank you.